Hello and welcome to today's lesson. Today, students will map transformations using coordinate notation. So we're going to use coordinate notation for our transformations. So first is, what are transformations? We've gone over this before. So there is a translation, which is just a slide. It can be horizontal, vertical, or both. There's reflection, which is just a flip over a line of reflection. Think of a mirror. Then there is rotation, which is just a turn around a center point. And finally, there's dilation, which is just an increase or decrease in size. We use a scale factor. Think of how your eyes dilate. So let's talk first about translations. So translation, again, is a slide. It can be horizontal, vertical, or both. So the mapping for this would look something like this. X, Y, which is our starting, goes to x minus 2, y plus 3. That means I'm moving it left 2, and then I'm moving it up 3. So if you look over here at the image right here, you can see that I started out with this blue square, rectangle, quadrilateral of some kind. I've got my original points listed, and we're going to look at what each point is going to move to. So, for each x value, I'm going to subtract 2. For each y value, I'm adding 3. So 1 minus 2 becomes negative 1. 2 plus 3 becomes 5. And if you look, that's where s is at. S is now at negative 1, 5. Q, again, we're going to subtract 2. So a 4 becomes a 2. We're going to add 3 to the 1, so that becomes a 4. So if you notice, that's at 2, 4. R, we're subtracting 2, so that becomes 3. Adding 3, so that becomes 7. And you can check that that's where that point is on the coordinate plate over there. And then E, we subtract 2, so 2 becomes 0. Add 3 to 5, so it goes to 8. So you'll always see for translations, it'll always look like we are adding or subtracting to our x or y values. Just remember that x values are horizontal, y values change vertically. Okay, so next let's talk about what is reflection. So reflection is just a flip over a line of reflection. Think about a mirror. Now the rules I'm giving you here only work when our line of reflection is our axis. So here, this one on the left, you'll notice that I am flipping over my y-axis. My y values stay the same. My x values change. So don't think of that as negative. So if I start out over here in the negatives, that means the opposite. So don't think of that as a negative. Think of that as opposite. So you'll notice that this bottom point started out at negative 4, negative 2. Its new location is negative 4. I'm sorry, it's positive 4, negative 2. Okay? So I notice I only changed my x value. Again, this only works for your axis. We do the same thing. We do the opposite. And then we reflect over our x-axis. We only change our y. Whatever axis we're reflecting over, that one stays the same. The other one changes. So here, let's look at this point right here. It started out as 1, negative 2.5. So again, our x does not change. We're still at 1. But now we're at positive 2.5. And that's exactly where that ended up at. Okay? So that, again, that happens for each point. So what about rotation? So rotation, it depends. With all these around the center point, your center point has to be your origin for any of these to work. Your origin, which is, remember, that's right here where your two axes meet. So if it is a 90 degree, remember all these are counterclockwise. Counterclockwise. So if it's a 90 degree, then our xy becomes negative yx. So think about it this way. If I had the point 3, 4, it's going to change to negative 4, 3. My y went here and changed signs. My x went to y and did that. Okay, so if I was doing this 180 degrees, a point value of 3, 4 would change to negative 4, negative 3. And same thing with 270. Oops, different color. So if it was 270 degrees, my 3, 4 would become 4, negative 3. Okay, so you just do exactly what it says in the mapping notation. Okay, finally, dilation is an increase or decrease in size. Remember, that's by our scale factor. So we multiply our points by our scale factor. So here I have a scale factor. Let's say we have a scale factor 2. This one actually is 1/2 because it's going from here to here. So remember, I see that little prime symbol. Okay, but let's say that our scale factor is 2. If my point is 1, 5, and my scale factor is 2, I just multiply it by 2. So it becomes 2, 10. If my scale factor is less than 1, if k is less than 1, it gets smaller, sorry. If k is greater than 1, it gets larger. And remember, we're not really talking much about dilation because we are talking about things that make congruent figures, and it's not make congruent. Remember, these are not congruent. We'll talk about them more in the next unit. But you just need to remember that for dilation, we multiply. Okay, if you have any questions, see me in class.